This technology made a very important impact on us. It changed the way how our history developed. But it's a technology so pervasive, so invisible, that we, for a long time, forgot it to take it into account when we talked about human evolution. But we see the results of this technology still. So let's make a little test. So every one of you turns to the neighbor. Please, turn your face to the neighbors. Please, also on the balcony. Smile, smile, open the mouth, smile friendly. Do you see any canine teeth? Count Dracula teeth in the mouth of your neighbors? Of course not, because our dental anatomy is actually made not for tearing down raw meat from bones or chewing fibrous leaves for hours. It is made for a diet which is soft, mushy, which is reduced in fibers, which is very easily chewable and digestible. Sounds like fast food, doesn't it? It's for cooked food. We carry in our face the proof that cooking, food transformation, made us what we are. So I would suggest that we change how we classify ourselves. We talk about ourselves as omnivores. I would say we should call ourselves cooktivores. From cookere, to cook. We are the animals who eat cooked food. No, better. To live off cooked food. So cooking is a very important technology. It's technology. I don't know how you feel, but I like to cook for entertainment. And you need some design to be successful. So cooking is a very important technology because it allowed us to acquire what brought you all here, the big brain. This wonderful cerebral cortex we have. Because brains are expensive. Those who have to pay tuition fees know. But it's also metabolically speaking expensive. You know, our brain is 2 to 3% of the body mass, but actually it uses 25% of the total energy we use. So it's very expensive. Where does the energy come from? Of course, from food. If you take raw food, we cannot release really the energy. So this ingenuity of our ancestors to invent this most marvelous technology, invisible, every one of us does it every day, so to speak, cooking made it possible that mutations, natural selections, our environment could develop us. So if we think about this unleashing human potential, which was possible by cooking and food, why do we talk so badly about food? Why is it always do and don'ts, and it's good for you, it's not good for you? I think the good news for me would be if we could go back and talk about the unleashing, the continuation of the unleashing of the human potential. Now, cooking allowed also that we became a migrant species. We walked out 2 times of Africa. We populated all the ecologies. If you can cook, nothing can happen to you. Because whatever you find, you will try to transform it. It keeps you also your brain working. Now, the very easy and simple technology which was developed actually runs after this formula. Take something which looks like food, transform it, and it gives you a good, very easy, accessible energy. This technology affected 2 organs, the brain and the gut, which actually are affected. The brain could grow, but the gut actually shrank. Okay, it's not obvious, to be honest, but it shrank to 60% of a primate gut of my body mass. So, because of having cooked food, it's easier to digest. Now, having a large brain, as you know, is a big advantage because you can actually influence your environment. You can influence your own technologies you have invented. You can continue to innovate and invent. Now, the big brain did this also for cooking. But how did it actually run this show? How did it actually interfere? What kind of criteria did it use? And this is actually taste, reward, and energy. You know, we have the 5 tastes, 3 of them sustain us. Sweet, energy. Umami, this is a meaty taste. You need proteins for muscles, recovery. Salty, because you need salt, otherwise your electric body will not work. And 2 tastes which protect you. Bitter and sour, which are against poisonous and rotten material. But of course, they are hardwired, but we use them still in a sophisticated way. Think about bittersweet chocolate, or think about the acidity of yogurt, wonderful mixed with strawberry fruits. So we can make mixtures of all this kind of thing, because we know that in cooking we can transform it to a form. Reward, this is a more complex and especially integrative form of our brain. There are various different elements. The external states, our internal states, how do we feel, and so on, are put together, and something which maybe you don't like, but you are so hungry that you are really will be satisfied to eat. So satisfaction was a very important part. And as I said, energy was necessary. Now, how did the gut actually participate on this development? And the gut has a silent voice. It's going more for feelings. I use the euphemism digestive comfort. Actually, it's a digestive discomfort which the gut is concerned with. If you get a stomach ache, if you get a little bit bloated, was not the right food, was not the right cooking manipulation, or maybe other things went wrong. So my story is a tale of 2 brains, because it might surprise you, our gut has a full-fledged brain. All the managers in the room say, you don't tell me something new, because we know gut feeling, this is what we are using. And actually you use it, and it's actually useful, because the gut is connected to our emotional limbic system. So they do speak with each other and make decisions. But what it means to have a brain there is that not only the big brain has to talk with the food, and the food has to talk with the brain, because we have to learn actually how to talk to the brains. Now, if there is a gut brain, we should also learn to talk with this brain. Now, 150 years ago, anatomists described very, very carefully. Here is a model of a wall of the gut. I took the 3 elements, stomach, small intestine, colon. And within this structure, you see these 2 pinkish layers, which are actually the muscle. And between this muscle, they found nervous tissues, a lot of nervous tissues, which penetrate actually the muscle, penetrate the submucosa, where you have all the elements for the immune system. The gut is actually the largest immune system, defending your body. It penetrates the mucosa. This is a layer which actually touches the food you are swallowing and you digest, which is actually in the lumen. Now, if you think about the gut is, when you could stretch it, 14 meters long, the length of a tennis court. If you could unroll it, get out all the folds and so on, it would have 400 square meters of surface. And how this brain takes care for this, to moving it with the muscles and to defend the surface. And of course, digest our food we cook. So, if we give you a specification, this brain, which is autonomous, has 500 million nerve cells, 100 million neurons, so around the size of a cat brain. So there sleeps a little cat. Okay? Thinks for itself, optimizes what Heribert digests. It has 20 different neurons types. So the same diversity you find actually in our big brain, where you have 100 billion neurons. It is autonomous, organized in microcircuits. It has these programs which run. It senses the food. It knows exactly what to do. It senses it by chemical means, very importantly by mechanical means, because it has to move the food. It has to mix all the various elements which we need for digestion. This control of muscle is very, very important, because, you know, there can be reflexes. If you don't like a food, especially if you're a child, you gag. It's this brain which makes this reflex. And then finally, it controls also the secretion of this molecular machinery which actually digests the food we cook. Now, how do the 2 brains work with each other? I took here a model from robotics. It's called the subsumption architecture. What it means is that we have a layered control system. The lower layer, our gut brain, has its own goals, digestion, defense, and we have the higher brain with its goal of integration and generating behaviors. Now both look, and this is the blue arrow, both look to the same food which is in the lumen, in the area of your intestine. The big brain integrates signals which come from the running programs of the lower brain, but subsumption means that the higher brain can interfere with the lower. It can replace or it can inhibit, actually, signals. So if we take two types of signals, a hunger signal, for example, if you have an empty stomach, your stomach produces a hormone called ghrelin. It's a very big signal. It's sent to the brain and say, go and eat. You have stop signals. We have up to 8 stop signals. At least in my case, they are not listened to. Okay? So what happened? If the big brain in the integration overrides this signal. So if you override the hunger signal, you can have a disorder which is called anorexia. Despite of generating a healthy hunger signal, the big brain ignores it and activates different programs in the gut. The more usual case is overeating. It actually takes the signal and changes it, and we continue. Even our 8 signals would say, stop, enough, we have transferred enough energy. Now the interesting thing is that along this lower layer, this gut, the signal becomes stronger and stronger if undigested but digestible material could penetrate. This we found from bariatric surgery, that then the signal will be very, very high. So now back to the cooking question and back to the design. We have learned to talk to the big brain, taste and reward, as you know. Now what would be the language we have to talk to the gut brain that its signals are so strong that the big brain cannot ignore it? That we would generate something all of us would like to have, a balance between the hunger and the satiation. Now I give you from our research a very short glimpse. This is fat digestion. You have on your left an olive oil droplet. And this olive oil droplet gets attacked by enzyme. This is an in vitro experiment. It's very difficult to work in the intestine. Now, everyone would expect that when the degradation of the oil happens, when the constituents are liberated, they disappear, they go away because they absorb. Actually, what happens is that a very intricate structure appears, and I hope you can see that there are some ring-like structures in the middle image, which is water. This whole system generates a huge surface to allow more enzyme to attack the remaining oil. And finally, on your right side, you see a bubbly, cell-like structure appearing from which the body will absorb the fat. Now, if we could take this language, and this is a language of structures, and make it longer lasting, that it can go through the passage of the intestine, we would generate stronger signals. So our research, and I think the research also at the universities, are now fixing on these points to say, how can we actually, and this might sound trivial now to you, how can we change cooking? How can we cook that we have this language developed? So what we have actually, it's not an omnivorous dilemma. We have a cognivorous opportunity, because we have learned over the last 2 million years with taste and reward, quite sophisticated to cook, to please ourselves, to satisfy ourselves. If we add the matrix, if we add the structured language, which we have to learn, when we learn it, that we can put it back, and around energy, we could generate a balance, which comes out from our really primordial operation, cooking. So, to make cooking really a very important element, I would say even philosophers have to change and have to finally recognize that cooking is what made us. So I would say, coco ergo sum. I cook, and therefore I am. Thank you very much.